Okay, so let's continue where we left off yesterday. So we were finishing up this problem. So let me remind you, this problem was asking, are these two triangles similar? Are they similar using SAS Similarity Theorem? And so the first thing we did was we separated them, right? We got the small triangle, put it right here. And we got the large triangle, put it right here. And then we said, okay, in the small triangle, the sides are 15, 20, and 30. That's 15, 20, and 30. And then the large triangle, some of you said, oh, the side is 6. And I said, no, the side is not 6. The 6, hold on one second. The side is not 6. 6 is only this part. The whole side right here, right? The whole side right there, you have to add 15 plus 6. And what is 15 plus 6?
21.
Yes, thank you. 15 and 6 is 21. There you go. And so the same thing goes over here. That's 8, right? But that's not the whole side. If we want the entire side, we have to add 20 plus 8, right? This plus that. And 20 plus 8 is?
21.
No, it's 20. It's 28. It's 28. Okay, so then, and then this is 42, right? This side right here is 42, so we put that there. So we have both. And then we marked up the sides with colors. The matching sides of the small triangle and the large triangle, we match them up with colors. So we see this side matches up with this side. This side matches up with this side, so I made them both pink. And this side matches up with this side, so I made them both orange. Okay, and then now we got to see if the sides are proportional. And the way to do that is to make ratios. And the way something's proportional is if all the ratios are equal. And we need to have all 3 of the corresponding sides equal ratios, right? So that's where we stopped yesterday. So what we're going to do is we have the green. So let's do the green. We'll do the green ratio. Then we'll do the orange ratio. Then we will do the pink ratio. And let's see if they all simplify to the same number. So ratio is a fraction. So let's look at the green. And I get to decide if I'm going to go large to small or small to large. And I decided I'm going small to large. Doesn't matter which one you do. If you want to put large in the top and small on the bottom, that's fine, as long as you do the same thing for all 3. Okay, so I chose small over large. So I look at the green sides, the matching green sides, and the small one is 20. So I put that on the 20 on the top. And the large one is 28. Then I look at the orange, right? And then I put the small value, which is 30. Then I put the large side of the large triangle of 42. And then for pink, I put the small on top, I put 15. And then I put the small one on the bottom.
21.
Yes, thank you, 21. And now they don't all look the same right now. They don't look the same right now, but let's simplify. Let's simplify. So 20 over 28. What can I simplify 20 and 28 by? What can I divide the top by? I can divide by 4. Good job. So if I divide the top by 4, right? If I divide the top by 4 and the bottom by 4, I get 5 over 7. And then if I do the same thing over here for the pink, 15 divided by, what can I divide 15 by? By 3. Divide by 3, divide by 3. I get 5 over 7. So woohoo! That and that are equal. Okay, let's do the orange one. Because just because 2 are equal doesn't mean we're done. Remember we talked about that yesterday? So what can we divide 30 and 42 by? By 6. So let's divide by 6, and we get 5 over 7. Ha! I tricked you. Some of you thought I skipped the orange one because that was going to be off. No, they're all 5 over 7. So guess what? These triangles are similar because of SSS Similarity Theorem. Woohoo! There we go. Yeah. We're not done now. Now we have to do one more thing. We have to give our similarity statement. We have to give the similarity statement, right? We have to say triangle blank, blank, blank is similar to triangle blank, blank, blank. So let's write that up here. Triangle blank, blank, blank is similar to triangle blank, blank, blank. So remember, we need to put the blank, 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 the corresponding vertices in the same order. Okay, so if I look here, Well, I'm going to start with W because W is the same in the small triangle and in the large triangle. So I'm going to start with W. Doesn't matter which one you start with, as long as they match on both sides. They match here and here. If I put W first, then I got to put W first over here because those are matching. You got to put them in the same order. Okay, so now let's do, so I'm going to go small to large. I'm going to put the small right here and the large right here, kind of like I did here. And so now let's look here at X. Well, X, what does X match up with? Well, if you can't tell, we'll look at the colors. Pink and orange. It's where pink and orange meet. Oh, over here, pink and orange. Y. So X and Y match. So I'm going to put X second, and it matches up with Y. And then if we look down here, V, well, what does V match up with? Well, it's green and orange. So green and orange is U. So V and U match up. So V on the small, U on the large. And there you go. Mister. Yes, student? I did it different. Okay, what did you do, student? I put triangle VXW first. Okay, so if you put triangle VXW first, you're not wrong. Just make sure when you put the second triangle, the larger one, you put in the same order. What do you mean same order? I mean the order that matches. So you put the order of the same corresponding pieces. So V, what matches with V? Oh, V matches with U. Yeah, so you would put U first. And what matches with X? X and Y match. Good job. So that means I'd put Y next. And then what matches with W? That was the easy one. W and W match. Good job. So I'd put W. So if you did it like that, as long as the order you put it in matches with the second triangle, right? First, those match. Second, those match. Third, those match. Does that make sense? Okay, so that's what I wanted to finish up yesterday. So now that you've done that, I'm going to give you a minute to look at that and copy it and ask any questions. So I'll give you a minute to do that. All right, time is up. So now let me give you the warm-up problem. So this is the one I want you to try. I want you to try this one on your own. And it is SAS Similarity. So you are going to practice the SAS Similarity. So look at this. Look at this problem. I will give you 7 minutes. Give you 7 minutes. To do the warm-up. All right, time is up. Let's go over this. And remember, stop me if I'm going too fast, if you're not understanding. And remember, you all have A's right now. So to keep those A's, you need to understand the stuff. Yes, I know you need to do the work, but if you're going to do the classwork and homework and you're going to do it well, or do it, to get full credit, or do well on the quizzes when we take the quiz, you got to understand this stuff. So you got to ask those questions. So please don't ruin that A. All right, so the first thing we're going to do is we're going to match up the sides. So we notice here they do give us the length of the sides of both triangles. So that's good. So now we got to match them up. So we need to make our ratios, but before you make your ratios, you need to know what sides match up with what. So so look at it first. This kind of looks like this triangle was flipped over this way, kind of like reflected, right? Like if you flip it, I picked it up and then I flipped it upside down over here. So that means if that happened, that means this side matches with this side. That means this far side over here flipped over to this far side over here, and then this side flipped to here. You guys see it? You guys see how that flipped over like that? Okay, so that's the first thing you need to do. You need to identify the matching pieces, which ones correspond with each other. And then once you do that, easy street. Now I just make my ratios. Make my orange ratio, make my green ratio, make my pink ratio. Super easy. So ratio just means I'm comparing. So you have to decide, do you want small over large? Remember, this is the small one. This is the large one. Do you want small over large, large over small? Let's do large over small. Doesn't matter which way you do it. It's just a choice you have to make. And once you make that choice, it has to be done for all three ratios. You can't flip it again, okay? Put the large on the top, small on the bottom. That's the choice you make. If you want to do small over large, you can do that too. Just as long as you do the same for all three of them, right? Do the same thing for all three of them, whatever you choose. And this is what I choose. And then to see if you get the same number. All right, so I'm doing large to small. So let's do the orange one first. So the orange one, large to small. So orange is here and here. So the large one is 18 and the small one is 5. So I put 18 on the top and 5 on the bottom. Then I go over here to the green. Green is 54 and 15. So I'm going to put the large on the top and the small on the bottom. So 54 and 15. And then the pink, 43.2 and 12. Uh-oh, I don't like that point, that decimal. That might throw a wrench into what we do. But it's okay. Let's see what we're doing. 43.2 over 12. So if you look here, 18 over 5. Can you simplify 18 over 5 by anything? Can I divide 18 and 5 by any number that's the same? No. Someone in the chat said, no, you can't, mister, because 5 is just 5 times 1, and 18 is 2 times 3 times 3, and nothing matches there. So I can't simplify that. So you're thinking, if I can't simplify that, that means, let's see if we can simplify this. Can I simplify this by anything? 54 and 15. What can I divide 54 and 15 by? By 3. So yes, I can divide by 3. So divide by 3, divide by 3. And I get 54 divided by 3, guess what? Is 18. And 15 divided by 3 is 5. So that works, 18 over 5. So they match. But if I look over here, 43.2 and 12, can I simplify that? Not like this. So, you know what another thing you can do? You see how it's 43.2? You can change these fractions to decimals. You can do that also. You can change it to decimals and see if you get the same thing. So I'm going to get my handy dandy calculator. And I'm going to say, what's 43.2 divided by 12? And I get 3.6. So now what I'm going to do is I'm going to come over here and see if 18 over 5 is also 3.6. So I'm going to say 54. I'm going to do the original. 54 divided by 15 equals 3.6. Some of you are saying, mister, somebody in the chat, how did you do that? How'd you do that? How'd you get that decimal? You get the decimal by just dividing the top by the bottom. Top by the bottom. Okay, 54 divided. That's what that division sign. You ever know this? That division sign. You ever look at the division sign? You know why the division sign is like this? Because this represents a fraction. You guys know that? The division sign is a fraction with a dot for the numerator and a dot for the denominator. Some of you are like, what? Wait, what? My mind is blown. What? Yes, that's why the division sign is like that, because it just means a fraction. And so a fraction is division. Top divided by bottom. So let's do that. 18 divided by 5. We get 3.6. So if we look here, we have 3.6, 3.6, 3.6. Guess what? They all are the same. That means this triangle is 3.6 times bigger than this triangle. And so we say yes. Yes. These triangles are similar by SAS Similarity Theorem. Happy face. And so now that we know that they're similar, let's write our similarity statement. So triangle blank, blank, blank is similar to triangle blank, blank, blank. So I'm going to start with A. Let me start with A. Okay, so A is pink, green. And if we look here, pink, green is T. So A and T match. So I'm going to put A and T. And then if I look over here, P is pink, orange. And Y is pink, orange. So P and Y match. So I'm going to put P and then Y. And then over here, green, orange is R. Green, orange is R. So R and R match. There you go. There's your similarity statement. But mister, yes, I hear you. You told me this last time. You did it differently, did you? Yes, I did it different. Okay, so how did you do it? I did triangle PAR is similar to triangle. Okay, hold on. Pause. Triangle PAR. So let's make sure we do this right. So what does P match up with? P and Y match up, don't they? So that means I'd have to put Y first over here. And then what matches up with A? A matches up with T. So I'd have to put that second, T. And then R matches up with R, so I'd have to put R. So it doesn't matter the order you put it as long as you make sure that they're matching, that the first letter you put here matches the first letter here, P and Y. Yes, P and Y are corresponding. They're matching. A and T, right? A and T are matching. And then R and R. Okay? So yeah, you can do any order as long as you stick with the order that they are matching. Okay, any questions? Okay, I'll leave this up for a minute for you to copy. Did anyone know that the division sign was a fraction with a dot for the numerator, dot for the denominator? Or did any of you have your mind blown? No one. Is anyone even? You're like, Mister, spring break's in about 20 minutes, so we're not even listening to you. Please listen to me. Please. This is how you keep your A. Right? I'm just asking a question. Please pay attention for the next 20 minutes. It's kind of blurry. Okay, do you want me to zoom in on any part? Yeah, somebody just said, hey, mister, the videos from the last 2 days aren't up. Yes, they are not up because I tried to upload them 2 nights ago. In the middle of uploading, it had an error. So I did the same thing last night. Remember I told you last night I was going to upload both of them. The same thing happened. So I'm going to try again tonight. I'm going to upload all 3. And so if you guys need more time, to turn in your classwork or homework, we're going to start our classwork in a little bit. But if you need more time to do your classwork and homework, you can turn it in anytime during spring break. The reason the due date's tomorrow is because I didn't want you to do work during spring break. But if you want to turn it in this weekend, or if you want to turn it in during spring break, and if you're waiting for the videos, like, Mister, I want the videos to go back up so I like looking at them and it helps me remember. And it's a lot clearer than the Zoom because the Zoom is so blurry. Yes, I get that. You can do that. So you are all welcome to turn in your homework and classwork during the break without penalty. I won't take away any points. It's just I didn't want you to do it during break because I want you to enjoy your family and stuff during the break. I don't want you to focus on math. But if you can if you want to. Remember, that's how you're going to keep your A. Those of you, everyone has an A right now. If you want to keep your A, you got to understand AA similarity, SSS similarity, and then what I'm going to show you right now, SAS similarity. And then you have to do the classwork and homework. Classwork, we're going to start today. The homework has been there for the past couple of days. You should have been starting it. If you haven't, shame on you, but you have a few days. You can turn it in during the break. And that's how you keep your A. Mister, how do I keep my A? Do those 2 assignments and understand what I'm teaching you. All right, so the last thing I'm going to show you, and then we're done and we can go on to spring break, is SAS similarity. And it's exactly the way it sounds. 2 sides and the angle in between them. It's exactly the way it looks. You got 2 sides and then the angle that's in between them, called the included angle. So if you can find 2, and then I'm going to add this, 2 pairs of corresponding sides that are proportional, right? That means the ratios are equal. So this time you only have to find 2 pairs of sides. And the included just means between, right? In between. The included angle are congruent, then the triangles are similar. So in order to do this, you got to find 2 sides and the angle in between it. Okay, I'll give you a second to copy this. And if you can do that, then you can also say that the 2 triangles are similar. So there's the 3 ways: AA similarity, SSS similarity, SAS is the new one. Okay, so let me go on to a problem. Let me show you. So here's an example. Determine if this is similar by SAS similarity. If yes, write the similarity statement. So here we go. So if we look here, ooh, they already give us an angle. K and N are already equal. So good. So we already have this. Check. We only need 2 more things. So now let's look at the sides. So let's mark up the matching sides. This side, KJ, matches with this side, NM. And if we look over here, KL matches up with NP. And the third side matches up. We don't have to put it. If you want to, you can. This side matches with this side. But if you notice, they didn't give any length there. So we don't have to put anything there. But that we know that side matches with that side. So if I look here, I only have to look at green, right? The green ratio and the orange ratio. So let's look at the green ratio and the orange ratio. And I'm going to put large over small because the large one is on here and the small one is on here. Some people are telling me, Mister, you know how you say I have a choice for how I write my ratios for these problems? And I said, yes. And they said, I don't like choice. And I said, excuse me? They're like, yeah, mister, I don't like choice. That means I have to choose something. And sometimes it takes me a long time to choose. I'll have an argument with myself, mister, saying, I'm going to try large over small. And then another piece of my brain says, why don't you try small over large? And then my other piece of my brain says, yeah, that's a good idea. Then I start having a little argument with which one I should do. And then, So if that's you, right? If that's how you think, because choice gives you too much to argue yourself with, the way I do it is I just look from left to right. And since large is here and then small is over here, that's what I do. I put large and then small. So if you're having trouble making a choice, just do it that way. Whichever one's on the left side, put on top. Whichever one's on the right side, put on the bottom. Bam, there you go. So there's problem solved. Remember I told you I'm a problem solver. If you're having a dilemma that you can't solve, come and talk to me. We can talk it out. We can come up with a solution. Everything can have a solution. Okay, most things can have a solution. Not everything. Most things can have a solution. So let's look at the green side. The green side, we're going to put large, which is 8, over small, which is 6. Now let's look at the orange side. We're going to put the large on top, which is 20, and the small on bottom, which is 15. And so if I simplify both, 8 over 6 becomes, if I divide by 2, I would get 4 over 3. And then if I do the orange, I simplify the orange by 5, I can put 4 over 3. And look at that. Look at that. They match. So we have 2 pairs of sides that have this, that are proportional. They have the same ratio, and the angle in between them is congruent. So guess what? These triangles are similar by SAS Similarity Theorem. There you go. Right, so that's all you got to do. You got to find 2 sides that have the same ratio, 2 sets of sides, 2 pairs of sides, and then the angle in between them. Not this angle, the angle that's in between those 2 sides. And those are the 2 sides we were looking at. We weren't looking at the purple side. So it has to be the included angle, the angle in between. All right, now that we know they're similar, we need to write our similarity statement. So we got to say triangle blank, blank, blank is similar to triangle blank, blank, blank. So let's do this. Let's say K is green, orange. N is green, orange, and duh, they're the matching ones because those are the ones that are congruent to each other, right? They're congruent, so I'm going to put K and N. And then if I look over here, J corresponds with M. Why? Because green, purple, so J and M. And then lastly, we have L and P, because that's orange and purple, L and P. So that'll be last. Mister, yes, I know, student. I know you did a different order. Yeah, I did it again. Okay, so what did you do, student? I did triangle LJK. You did triangle LJK. Okay. So if you did a different order, that's fine, as long as you put it the second one in the same matching order. So what does L correspond with? L and P. Exactly. So I'm going to put P first. And what does J match up with? J matches up with? It matches up with M. Yep, it matches up with M. So I'll put M second. And then what does K what does K match up with? Got to put that last. K and N. That's right, K and N, because look at that, they're the matching ones. So I put N last. All right, thank you, mister. You're welcome. You're welcome. Okay, so I'll give you a minute to look at that. That is SAS Similarity. All you got to do is find two proportional sides, and then the angle in between them is congruent, and you're good. And then you can say they're similar, and then write the similarity statement. All right, so here's what we're going to do now. If you go, and I'll come back to this if you're still copying. If you go to Schoology and you go to the proper course, make sure you go to the proper course, right? Because I remember I told you they're still there. I don't know why. Don't go to this one. That's quarter 3. See how it says A3 and it says Geometry Tutorial Lab? We're not there. We are here. Term 4, A4. Okay, so you click on that one. Go to week 11 and you'll see there's the notes at the top and the note solutions. You don't have to turn those in, but you'll see here at the bottom, homework and classwork. Those are the two things you're going to do. So if I click on classwork, you're going to look at classwork, and yes, you can do it with Cami. You're going to look at classwork and you're going to say, uh-oh, there's 18 problems, mister. That's a lot of problems. Guess what? I got a deal for you today, guys. I got a deal for you. It's a 2-for-1 deal, or actually a 1-for-2 deal. We're going to, not 2-for-1 means I would double it. We're going to do a 1-for-2 deal, meaning you only have to do 9 of these problems. You don't have to do all 18. Which 9, mister? Any 9 you want. You can do the evens, you can do the odds, you can do the first 9, you can do the second 9, you can do 4 on one page, 5 on the other, 5 on one page, 4 on the other. Doesn't matter. Only have to do 9 of the 18. Wow, you're great, mister. Yeah, I know. Thank you. Thank you. Okay, so does everyone understand that? On the classwork, there are 18 problems. You only have to do 9. Any 9. Okay? You only have to do 9 problems. Somebody first period said, oh, you mean I only have to do number 9? No, that's not what I meant. You're doing 9 problems instead of 18. That means I'm taking half of them away. And then do all of the homework. You need to do all of the homework. And that's it. And then you do those 2 things, you continue to keep your A. Does everyone understand what I'm saying? So I'm going to open up some breakout rooms if you want to go work with your friends. Okay. Or you can stay here in the main room. And then you have Miss Torres, Miss Preciado, Miss Rivas in here. If you want them to help you or go into a room or anything, we can all help you. Okay. So the rooms are open if you want to go there. So that's what we're doing the rest of the period. We're working on this classwork and the homework. They're both due tomorrow, but like I said, if you need more time, you can turn them in this weekend. You can turn them in during the week next week, but I don't recommend that. I want you to enjoy your spring break. So that's what we're going to do. So that's what we're doing right now. Go ahead and can work in class until class is over on the classwork and the homework.